Numericals on mutual inductance. Question number 1. What is the mutual inductance of a pair of coils if a current change of 6 ampere in one coil causes the flux in the second coil of 2000 turns to change by 12 into 10 power minus 4 Weber per turn? So let's consider the solution. So here we are given N equal to 2000 and I is given as 6 ampere. Flux per turn, phi per turn is given as 12 into 10 to the power minus 4 Weber. And we can find total flux. So total flux will be equal to flux per turn times number of turns. So 2000 times 12 into 10 power minus 4 Weber. That will be 2.4 Weber. Now we know that phi equal to mi. So this will give m equal to phi upon I. So we put the value of phi. Phi is 2.4 divided by I is 6 ampere. So this will be 0.4 Henry. Let's see next question. The mutual inductance of two coaxial coils is 2 Henry. The current in one coil is changed uniformly from 0 to 0.5 ampere in 100 milliseconds. Find the change in magnetic flux through the other coil. And the second point, EMF induced in the other coil during the change. So d phi is m di. This is from the fact phi equal to mi. We write the change. So we get d phi equal to m di. So we put the value of m is 2 and I changes from 0 to 0.5. So 0.5, that is 1 Weber. Now EMF induced is minus m di by dt. So minus 2 into 1 divided by time is 100 millisecond. So this will give minus 10 volt. Now consider next question. Next question is two concentric circular loops of radius 1 cm and 20 cm are placed coaxially. Find mutual inductance of the arrangement. Second point, if current passed through outer loop is changed at the rate of 5 ampere per millisecond, find EMF induced in the inner loop. So let's consider the solution. So here phi equal to mi and magnetic flux linked with the smaller coil is this. Now we know that field at the center, if this is true, so magnetic field at the center B is given by mu naught I divided by twice of radius. Suppose the radius is capital. So we find out phi equal to, we have B times A. So B is this much and the area will be pi r square. So B is mu naught I divided by twice of r times area is pi r square, so will be equal to mi. Now our purpose is to get m, so it will be equal to m equal to mu naught times pi r square divided by twice of capital R. So because there are two coils, one has radius 1 centimeter, other has radius 20 centimeters. So here small r is 1 and capital R is 20. So we put the values. So m equals mu naught is 4 pi into 10 to the power minus 7 times pi 3.14 into small r is 1 centimeter, means 0.01 square divided by twice of capital R, that is 20 centimeter, that is 0.2. So if we simplify it, we will get 10 power 9 Henry. Now we know that E equal to minus M di by dt. So we have got the value of M as 10 power 9, put here minus sign, times di by dt. Current changes 5 ampere per millisecond, that is 10 power minus 3. So this will come out to be 5 into 10 to the power minus 6 volt. Now let's see next question. A solenoid of length 50 centimeter with 20 turns per cm and area of cross section 40 square cm completely surrounds another coaxial solenoid of same length. Area of cross section 25 square cm with 25 turns per cm. Calculate the mutual inductance of the system. So let's see. So here small L is given as 50 cm, that is 0.5 meter, and the total number of turns in outer solenoid. So suppose it is N1, so number of turns per unit length into length. So number of turns per unit length is 20. So 20 into length is 0. Number of turns per centimeter. Length is 0.5 meter, that is 50 centimeters. So here we multiply 50, so we get 1000. And the area cross section of outer solenoid, suppose A1. So this is given as 40 cm square. That can be written as 40 into 10 to the power minus 4 meter square. Total number of turns in inner solenoid into number of turns in inner solenoid. So that is equal to number of turns per unit length times length. So number of turns per unit length is 25, length is 50 centimeter. So this will give 1250. So 1250 we have got into. Now area of cross section A2 is given as 25 centimeters square, that is 25 into 10 to the power minus 4 meter square. Now we have to find out mutual inductance. So M is given by mu naught and 1 and 2 divided times area of inner solenoid. So that will be A2 divided by common length. So we put the values. M equals mu naught 4 pi into 10 to the power minus 7. Number of turns in N1 is 1000. N2 is 1250 into area of inner one is 25 into 10 to the power minus 4 divided by length is 0.5 meter. If we simplify it, so we will get 7.85 into 10 to the power minus 3 Henry, which is our answer. Thank you for watching.